your captain B Benoflin Sam is here. So today I'm gonna teach basics of trigonometry, part 3. Last time as a part 2, I have thought like this, like a relation between the sectors and that measurement of angles. Today we gonna see signs of trigonometric ratios and allied angles. That was reducible formula. So let's get started with, and also examples of homework also there. So you have to hold your horses and let's get started. And by the way, one exam is there conducted by IIT Madras Pravatak. That is the out of the box thinking through mathematics. So in this, if you attend this, you will think how to solve it. If you get grade A, then you can select any levels: level 1, level 2, level 3, level 4. It is free for course. In exam, I don't know how much fees they will ask, so have to register. Okay, in a website called OOBT registration. See, if you click means course registration, how to do? I have to register for yourself. So let's back to this one. Great. Where was I? Yes. Signs for trigonometric functions. Actually, you have known this one. We use this quadrant of the table. In this quadrant table, we can tell this is x, this is y. And here, this is a first quadrant, second quadrant, third quadrant, and last but not least, fourth quadrant. Here, the first quadrant is all or positive. In here, it is sine theta and cosec theta are positive. In here, we can take as tan theta and cot theta are positive. In fourth, the last but not least, the cos theta and sec theta, those are positive. So why I am asking me is, I'll tell you why. It was followed by allied angles. See, how to remember? I'll tell you. Or else, I wrote this one. Wait a minute. I wrote this one. So we can take that x is equal to cos theta and y is equal to sin theta. Why not? Let's do it. In here we take as x, this pair will take x and y. As this are all positives, I will experiment. The second quadrant will be like sine, so take as minus x and y. Here we can take like this, x and y. Why x and y, bro? Because here tan theta is equal to sine theta by cos theta, but these are negative, so you take as negative by negative, it cancels to positive. That's it, very easy, right? So it will be x and y. Finished. So here you take as minus both will come. They asked x and y. In here you take as x and minus y. So you have remembered, right? Understand actually? What I'm asking is, this x and y is in the positive side, right? So here it is a x, according to x, this is negative side, but this y is positive side. Same as this one. These are negative sides, so it should be negative. In here, We can tell this one as this one is negative, so we can take y is negative, and here we take x, then we can take a positive. So here we film like this, you can know in this one. So x and y will become like this. I'll draw like this. Okay, this is a referenciation. Okay, I'll put dot. So this is how you have to contribute like this. So, like this, it is used for the trigonometric ratios. You can take this all are positive. In here we take a sine theta and cosec theta are positive. In here we take a tan theta and cos theta are positive. Here we take a cos theta and sec theta are positive. I told you all are positive. So here you get positive everything, so it is positive. In here sine and cosec, so it's y is equal to sine theta. So you take this one. That's it. For tan, you have means tan is equal to sine minus cos. You get minus tan. That's how you get like this. Here tan theta and cos theta are positive in here. Third, but sine theta cancel come into like this. In cos and sec, this is positive. Okay, right? X is equal to cos theta. Okay. This is how to contribute this. And let's go for the trigonometric ratio of allied angles. I'll tell you one trick. Very simple trick. Here, for example, you take like this. Okay. First, I'll draw this one. See. Is equal to cos theta. Yeah. Cos theta. Yeah. Cos theta comes from or if you put reducing formula, we're doing in reduction. So we do this one. So cos 90 degree minus theta is equal to how much? This one. For cos it means it will change, right? So we have sin theta. Then 90 degree minus theta is equal to cot theta. Cot 90 degree minus theta is equal to tan theta. And you are very confused, right? Writing these formulas. Don't mind these formulas, man. Do without formulas. How do is? So I already told you again. This is all or positive. So sine and cosec are positive. Tan and cot are positive. Cos and sec are positive. Using this, we can do like the allied angles without formulas. How do is we take this and forget this. It is near 90 degree or 270 degree. Then it changes like this. Each other. Cos, then changes to cot, and cosec changes together to sec. These are changes, okay? And near 180 degree or 360 degree, it's no change. For example, I'll tell like this. Sine, we're using this, you can do this. For example, sine 120 degree, the very my favorite example, this one only. Here you can take like this as sine 90 degree plus 30 degree. So it's 90 degree plus 30 degree, which quadrant will come? The second quadrant. So 90 degrees here, then it goes here. Very simple, right? So if you take this, you get like, but one problem, see then the 90 degrees here, means I told you near 90 degree or 270 degree will changes like this. So changes means it will go like this, cos 30 degree. I know that cos 30 degree is root 3 by 2. That's how to find the answer, man. And I'll tell you how this one will come. If they come cos 330 degree. 330 degree means you can take like cos 360 degree minus 30 degree. It changes like this. Okay. So it doesn't change it. So you take as cos 30 degree. And how to see here? 360 degree will come in which one? The fourth quadrant. So it will be positive. So it will come like root 3 by 2 again. It's same. And one important thing going for the third one is what we can take. Ah yes. Cos 270 degree. Cos 240 degree. If you're taking this, first you take this 180 degree plus 60 degree. Right? So if you're taking this doesn't change. But the main problem is this 180 degrees, this one. It's like if it added anything, it will goes in the third quadrant. Third quadrant means you take as minus cos 60 degree. Because here tan and cos, cot or plus. So it will come minus here for cos. And if you take this, you take minus root 3 by 2. This is how to mainly propose like this. And in IOQM, they will tell only for 9 degree and 180 degree. For what? The reductional and like that. In my technique, I'm telling this. In IOQM teachers, they will teach only formulas. But I am teaching a trick method. So let's see the questions. I'll give only one question, and then the next question you can solve by yourself. The first one is tan. Second one is right. Second one is yes, tan 225 degree is equal to what? In here, we can kind of take this. So first question, this is very homework question. That's like giving like this homework only. This is tan 50 degree, 150 degree. How can you take it? So tan 180 degree minus 30 degree. So if we minus from 180 degree, so it becomes second quadrant only. Why we can take as see, this 180 degree. So they minus like this, then it goes here only. Yeah, in 150 degree, yeah, it will come. And it doesn't change, so we can take tan 30 degree. And here, sine, cosec are positive. So I will put minus here. So minus means the value you can take is minus 1 by root 3. It's very simple. And this one, it's a homework for you. Tan 225. Have to contribute like this. How? But I'll not tell that hint. You have to do by yourself. Okay. Yeah, very easy only. I'll tell one clue. that you can take from 180 degree. I'll tell you. Then the next question, I will not tell any clues. So understand this. For tan 225, you have to tell in the comments. That's all for this video actually. These are the homeworks, you have to do it. So make sure you like, subscribe and share.